Hey, in this video, I'm going to show you the 6 mistakes you're making as a Web3 developer that are keeping people from taking you and your project seriously. So in this video, we're going to talk about using professionally audited smart contracts. I'm going to show you how to use GitHub commits and pull requests to create a rich commit history for your application. I'm going to show you how to write tests for your Web3 application. Then we're going to talk about automating the build and deploy process through your staging and production environments using CI/CD. We're going to add automated vulnerability scanning. And then I'm going to show you how to create a professional looking README for the project page for your site. And we're going to do all of that using tools that are free. So even if this is your own personal portfolio project, you can still implement everything that I'm showing you here. And I'm going to show it all to you in under an hour, but only if I shut the hell up and we get started right now. We're going to start with Third Web Explorer. And this is where Third Web has compiled a bunch of smart contracts, and we could write our own smart contract for this, but in doing so, we're going to have to go write Solidity code, and then once that code is written, we need to get it audited so that we know that it's secure and not vulnerable through any known exploits, which also involves trying to find someone who's actually a decent and competent auditor and actually knows more about Solidity than you do. Or we can just bypass all of that and let Third Web do that work for us, which is what we're going to do. And we're going to be deploying the addition drop contract here. So we're going to click the deploy button. And then there's some info on here about the screen or about the contract that you can read through if you want. I've already read through it, so I'm going to click deploy now. First thing we need to do is upload our file, and I've got my NFT image already set here. So one thing I'll point out here, this is not the image that we're going to deploy to our production network or to the Polygon mainnet. There's a couple of reasons behind that. Number one, it's a completely different image. So as we're testing out our Web3 app, when we get to building that, we'll instantly be able to tell that we have used the right contract address and we're not accidentally pointing to the testnet when we should be pointing to prod or vice versa. The other thing is it adds a tiny, tiny bit of extra security for anyone who's going to use your app that prevents the possibility of someone with less than great intentions of minting your contract on the Mumbai testnet or any testnet, and then parading that around and perhaps using it to get money or otherwise exploit an uneducated consumer. So we'll just eliminate that possibility by making them completely different images. So the only way you can get our main NFT is from Mainnet. We need to give it a name. So we're going to call it Holder's Creed Testnet, because that's exactly what it is. We'll give it a symbol. And then we'll just give it a little description here. And then we've got to set some different parameters here. Primary sales recipient, well, we don't have any sales or revenue from this, but in case we do end up with them, that is my contract address. Same thing with the royalties. We're going to leave the percentage set at 0. And then my chain that I want to deploy to, I want to deploy to the Mumbai network because this is our test image. And we'll click deploy now. That's going to trigger our MetaMask window to pop up to sign the transaction. We'll verify that that looks right. It's the Third Web proxy. There's our estimated gas fee, and we can confirm that. And our contract was successfully deployed. So now we need to add our NFT to that. And to do that, we'll click on the NFTs tab here. We're going to do a single upload because every image minted from this will be the exact same image. We're not doing individual NFTs. Give that a name. We'll upload our file here. And again, it's going to be the same file that we uploaded before. You can have different images. If that makes you happy, go for that. And then we can also add different properties here, which really doesn't apply to this, but if you had an NFT or if you're doing different NFT images, then you may have different traits that you would apply for those. And we're going to click Lazy Mint because that's ready to go. And then once we get our MetaMask notification to sign that transaction, we can go ahead and click Confirm. And then while we wait for that transaction to mint, well, there you go, it's done. So never mind. No, I was just kidding. I was just going to say that while it's doing that, it's uploading the image to IPFS so that it will be stored there, and then updating the metadata on our NFT or on our contract here. And you can see the NFT listed here on our Third Web homepage. All right. So now we need to actually build the website to consume this or display it or give a way for our users to interact with it and mint their own copy of it. To do that, we're going to use the Third Web example site for creating an edition drop, and then we're going to add some stuff to it to just take it up another little notch. But basically all we're doing here, the main thing we want to see from this repo is this command right here, npx Third Web create, and then specify the template edition drop. So let's go do that. So I'm going to paste that command from the GitHub repo in there. That's going to kick off the template cloning process. Then it's going to ask me for the project name, which I'm going to call it Holder's Creed because that is the website name we're deploying to. And now it's going to spend a few minutes here downloading the dependencies and setting everything up in our little project here. And then we're going to be ready to start writing some code. So the next thing we're going to do is set up a GitHub repo to store our code. So I'm going to create a new repository screen here in GitHub. I've given my repository a name and I'm making it public, which means that you will have access to this code as well. So if you want to see the final results of any of this or go into it a little deeper, there's a link to it down in the description below. And we'll go ahead and click Create Repository here. And we need to copy that because we have an existing repository. So we'll switch over to my terminal here and then cd into that directory, paste those commands in. So now if we switch back over to my browser here and refresh this, we should see the code for the website, and there it all is. All right, so let's go ahead and fire this up and see what it looks like whenever it's running based on our cloned repo. To do that, we're going to need our contract address. So I'm going to come back over here to the Explorer, and that's our contract address right there. So we'll switch back over here, and then there's a comment here, put your edition drop contract address in there. And that's exactly what we're going to do. And then we'll switch over to our terminal and let's type yarn dev. So that should fire it up there. We'll switch back over to our browser and do a new tab, going to localhost. We'll let that load up and see what we got here. An awkward pause for dramatic effect. And there is our NFT, and it currently says sold out. Now, the reason that it says sold out is because we haven't set up our initial claim condition. So there's actually nothing to be minted here. So we're going to go back to our Third Web contract dashboard. This is where we created our NFT, and we're going to click on that, jump over to the claim conditions tab, and we're going to add our initial claim phase. So we can just leave this as calling it phase 1. The date and time to start, that's today right now, so that's fine. And then we're going to leave the number of NFTs to drop as unlimited. Charge, we're not charging anyone for this, so that's 0. Currency is Matic because we're on the Mumbai network. Anyone can change it. And then we're actually going to change this to 1 NFT per wallet. And so we'll save that claim phase. That's going to trigger a MetaMask notification because we have to write this information out to the blockchain. And so we'll confirm that. And then it'll take a couple of seconds for that to get written. Oh, there's the pop-up right there. All right, so now if we go back over to our screen here, that's going to refresh, and we can actually see that we can mint this token. We're not going to mint one just yet, though, because we have other work to do. The primary thing that we're going to do at this point is we're going to start writing tests, because like you just saw on the screen there, when there was nothing available, it said that there were, I can't remember the exact message, but it said there was nothing to mint. Now it's all set up and ready to go, so a person can mint one. And then after you mint, you're only allowed to mint one per wallet, so it shouldn't let you mint one after that. And those are all scenarios that we want to write tests for, so we're going to do that. So I added a file here in the repo called jest.config.js because I'm going to use jest to write my tests. Our tests themselves are going to actually mimic the folder structure of our project. So I'm going to create a new file here, and they're all going to go in a folder called _test_, and then from here we're just going to mimic the actual folder structure of our project. So the test that we're going to write is going to belong to pages index dot test.ts for TypeScript. Is that right? Feels wrong, but I think it's right. The other thing we need to do is install all of the components that we need for tests. So I'm doing a yarn add here, --dev to save it as a development dependencies, and then installing the things that we need for our testing, our Jest environment, our React testing library, and then TS_jest because we're writing our tests in TypeScript also. So we'll run that, let that install. All right, for sure, I did name that file wrong. It has to be .tsx, not .ts, but that's fixed. And I put in just a really simple, straightforward test here that's gonna fail because it's gonna render the page and look for something called hello world, which doesn't exist on our page. And I did that just to tee up the rest of this conversation. So let's go ahead and run that and see what happens. By the way, I'm using WebStorm as my editor here, just in case you were wondering, or didn't see in the upper left-hand corner there where it says WebStorm. Whatever, I don't judge. But more importantly, our test fails here. And if we scroll down through all of this, one of the things that we see is that it failed on an unexpected token export for our Web3 button. So I'm going to switch back over to my index.tsx, the file that we're actually testing, and point out some things, mainly this import statement right here. So this import statement is where we import the SDK and all the libraries from Third Web. And now all of these, what they're doing is going out to the blockchain and running different transactions and checks on the blockchain to make your Web3 app work. And we don't want to do that in tests, all right? Because as you saw, it causes our test to fail. That also means that it's going to go out and try to interact with the blockchain, which is slow, and we don't want our tests to run slow. But that would also mean that we would need to have an NFT and a contract out there stored somewhere just for our testing purposes, which makes our test dependent on stuff that we don't want to have it dependent on, right? So it just creates this huge series of one obstacle after another where it makes testing hard. And I think that's probably why a lot of people skip writing tests when they're building Web3 apps, but we're going to take a different path. We are going to write tests, and we're not going to call the blockchain. And so I'm just going to paste in a little bit of code here real quick. And by the end, it should hopefully make sense of what I did. I'm calling jest.mock here, and then I'm passing in the name of the module, which if we look back at our index file, all of those dependencies come from the Third Web Dev React module. And so we're just going to mock that module. And then we supply it with a factory that returns an object for each of those things that we imported. So if we look here, we imported use active claim condition for wallet. Here I'm returning use active claim condition for wallet, which is just a jest function, which is basically an anonymous function that always returns for you. And I'm taking that one step further and returning an object that has an available supply of 1, which I only know through trial and error getting ready to record this video for you. So some of the things that we're doing in here actually require different return values from this. For example, use claim conditions returns a thing called claim conditions, which I've returned up here and just returning an empty data array. But if we TLDR this and cut right to the point and say, quit rambling, Will, what I'm doing is I'm mocking all of these things. So when your app runs, it's going to go out to the blockchain. It's going to grab the values that it needs and return those. And they're going to be used in our code down here. Let me see if I can find something real quick. Okay, yeah, so here, claim conditions, which we know comes from our use claim conditions function. If the data on that has a length equal to 0, or if for each item returned in that, if the max claimable supply is equal to 0, then we're going to render the message, this drop is not ready to be minted yet, no claim condition set. All right, and so those are the things that we're going to use to mock out the expected text on our website for our testing phase, right? So we've got our mocks in here. Let's run our test again and fire that up. It should still fail. And this time it fails because it's not able to find an element with the role heading and the name hello world, which we know to be true because that's not actually the text on our website. As a matter of fact, we can go over here and look and it doesn't say hello world anywhere. So that's failing for the right reasons. But along with the output of why it failed, we also get some hints about what it does see. So for example, it does show us the H1 heading that was rendered, and that's the text, this drop is not ready to be minted yet, no claim condition set, which we were expecting because we've mocked out all of the blockchain calls, and so it didn't get that data back. And as a matter of fact, it didn't get that back because we set our claim conditions data return array to just an empty array. But let's get our test passing real quick, just by copying the text that did get rendered into the expected text here. And we're doing case insensitive regex, so we don't want any capitals in there. And so now let's run this again. And hooray, our tests have passed, which takes us to the next stage of this conversation. All right, so what are we really testing here? We talked a little bit about the things that we're importing and the things that we're doing here. And it really gets to this point now where you have to understand what the code that you've got on your screen is actually trying to do. In this case, we got the code from Third Web, but that doesn't absolve us of the responsibility of understanding what's being done there. So if we take the time to read through the code, it really kind of just boils down to this. We've got a title, a description, and an image. All that come from the contract metadata for our NFT. So we should probably test for those to ensure that that renders correctly. And again, we'll mock that data. The claim supply, sometimes we get that number. If we do, it's the number of NFTs that have been claimed. And then really the meat of the application comes from this claims condition data. If that's an empty array, or if the elements in that array have a max claimable supply equal to 0, then we display the message not ready for mint. Otherwise, we should have some quantity buttons that allow them to choose how many NFTs they want to mint, unless our NFT is sold out. If it is sold out, we should render the sold out text. And if it's not sold out, then we should render our Web3 button that allows them to mint that NFT. So we need to write tests for all of those conditions. And here are the rest of the tests that I wrote for this. And so they're all very, very similar to this first one that I wrote here. So I just dropped them in all at once for you. And we're just going to go through some of the differences. The main difference, if you remember back to the flowchart that I showed you earlier, the main differences in our application come from the data that we get back from our smart contract that we deployed. And originally here, I had this jest.mock function that would go ahead and mock everything out. And so what I did is I pulled some of this stuff out. For example, if we take a look at use claim conditions, it's now calling a function called mock claim conditions. And so if we go look at mock claim conditions, it's returning the exact same thing that it did before. The difference being, let me grab one that's actually modifying that. In this specific test, I can now call mock claim conditions mock return value and change the data that gets returned. And that's how I'm changing what's getting displayed on the screen. Obviously, if the max claimable supply goes up, then that's going to change what the screen displays for our user. And then one other thing worth pointing out here is I put in this before each block in there. And so before each test runs, that runs just clear all mocks, which resets all of those mocks to their initial value. And that just ensures that the value from one test doesn't interfere with the test that you're currently running, right? Because different values will cause different behaviors, which can cause your test not to render or your page not to render like you were expecting. So that's tests for you. Again, the GitHub repo is linked below. You'll see all of this in there if you go look at that and you want to dig into it in more detail. The thing that we need to do now is we need to make sure our tests run automatically. The next thing we need to do is set up our GitHub actions so that the tests we have written run whenever we open pull requests and merge to main. So we're going to create a new file to do that. That's going to be in our .github folder under the workflows subdirectory, and then we're going to call it just ci.yaml. And let's crank that font up a little bit for you here. And so we'll give it a name of our node.js CI, spelled correctly, and then on push to branches of main, and on pull request, we want that to run on all pull requests, so we're going to leave that blank. We're going to run the following jobs. We'll have the build that runs on Ubuntu latest, and then our steps will be uses actions / checkout at v3. We'll give that a name of use node.js, and we're going to run 16 here. And actually, I think 18's out, so I probably should have used that, but we're too far into this video to change that now. So we'll do uses actions setup node at v3 with node-version, and we want that to be equal to 16.x, and then we want to run npm run CI. If we take a look at our package.json here, crank that font up for you. I added a CI command here that runs yarn install immutable cache, check cache. Basically what that does is install all of the dependencies, but using our yarn lock file, and it pins it to the exact version that I've got in that yarn lock file so that we don't have to worry about some other dependency that we weren't aware of changing, getting updated, and blowing up our tests, all that kind of good stuff. So we'll run npm run CI, and then we will run npm run test CI, and that's also in my package.json file here. It runs just with the --CI flag. So normally just will try to run and then wait for you to make changes to the file and rerun the tests again. That's not going to work on a CI server. And a lot of CI/CD servers will set an environment variable called CI for you so that your test suite knows not to do that. But just to be on the safe side, in case the CI server that you're using doesn't do that, we've got just --CI set up here for you. And I think this will get us started. That should run our tests and our GitHub action. So we need to come down here, create a new branch, and we will call this add tests. Jump over to our commit window here, and we can add all of these files in here. I think I've shown you all of these. Either I showed them to you or they're just standard files that I got right from, like the Just setup I got right from the Just website. Didn't do anything to change that. But either way, you'll be able to look at this pull request and see the exact details there. So our commit message is add initial tests. We're going to commit and push. Character turn line feed separators. Yeah, we can fix and commit that. Somebody must have been using a Windows machine. So let's go back over here to that one. Oh, we got some warnings here. Let's see what those are. Unused import, that's okay. And L. All right, so the warnings I'm getting here, I used an image tag, and this is a Next.js project, and it's saying we should use the next image tag instead of an image, an HTML image or React image. But we're not going to do that because I'm not going to be hosting this on Vercel. So we're going to commit anyway and push. Push all of those up. And there we go. So we'll do compare and pull request. And when you come look at the repo, if you want to see the exact files that were changed for this section of the video, this is the pull request you're going to look at. So we'll hit create pull request. This is ready to merge in. Review is required, but since I'm the only one here, I'm going to use my administrative privileges to merge that pull request, merge that in, and we can delete that branch. So I'm going to switch back over to my code here, go check out the main branch, and then pull that in, merge the incoming changes. So we've got fresh code here. And we're on to the next step of our building our app. All right, the next thing that we want to set up here is using Snyk for vulnerability and code scanning. And if you're not familiar with Snyk, it's a security tool that's going to allow us to identify any dependencies that have security vulnerabilities that are known and help us manage those so that we always are using secure software in our application. This is the Snyk homepage here. You can see where I've already added my project to Snyk and it's done the initial check on it. But the thing that we want to do is make sure that we do a scan on our code every time we push new code to the repo. So what we're going to do here is create another GitHub Actions file. This one's going to be called security.yaml. And then we're going to add our Snyk integration to it. So we're giving it a name of security build. And then on push is when we want it to run these jobs. The first job we're going to run is the vulnerability job, and we'll give it a name of Snyk vulnerability scan. It runs on Ubuntu latest and performs the following steps. It's going to check out the code using the standard GitHub action, and then we're going to run Snyk itself. That's going to come from the Snyk action, and then I'm putting continue on error here as true, just so that if it does find an error, and for whatever reason, this really needs to get deployed and we'll address whatever it found later, then this will allow the job to continue even though it found a vulnerability. We need to set up the environment, and basically the environment includes the Snyk token so that it knows which Snyk account I'm using. And then we pass in a couple of args here, one for the organization, which is the Snyk organization I have set up with Snyk, and the other is to only alert on severity threshold of high or critical. Next, we're going to run a Snyk code analysis. Again, that runs on Ubuntu latest, and we're going to check out the code using the GitHub action. And then the action itself from Snyk comes from the Snyk actions. Again, continue on error, passing in our security token. Then for our args, we will only pass in the Snyk organization, and then we'll give it a specific command to run, which is code test, and that will cause Snyk to run a static code analysis on our code whenever we push this code up. So that looks good. Again, I'm going to open up a new branch here and call this Snyk integration. We'll create that, go over to my commit window here, add that file, and our commit message will be add Snyk to GitHub Actions. We'll commit that, push that up to the repo. So now if we come back over to my repo here, we've got our new code that we pushed up. So we'll open up a pull request for that. We'll create that pull request. So we've got our Snyk scans that we just configured that ran automatically for us. Those are all green checks. And so I can go ahead and merge this. We'll delete that branch. And actually, if we jump over to actions now, so now it's actually running the test to make sure that all of our tests still pass for our code that we wrote in the first part of this video. Okay, so I know what you're thinking. At this point, the video is probably getting pretty long. And you're like, dude, we haven't even done very much of the NFT thing yet. What are you doing? And that's kind of the point that I wanted to highlight in all this, because true, we haven't done any shiny, cool, like Web3 type stuff yet. But what we have done is really, really important and is by far the most overlooked thing that I see in every Web3 application that I work with. Because let's think about what we did. We put in our security scanning to check for known vulnerabilities. We did code analysis to check for good code practices, and we're writing tests for our code to ensure that no matter what happens within our app, that the right thing is displayed for the user. And that's all pretty boring stuff. It's much more exciting to go focus on the shiny new cool part of building your app so you can get it launched and get people buying your NFTs or minting your NFTs or whatever it is your app is doing. But here's the thing, this stuff that we've done so far in the video is the cornerstone. It's the foundation that will make the shiny, cool, exciting parts of your app sustainable for years down the road. So don't just kind of discount this and think it's boring, mundane stuff. It's actually the cornerstone of your app, because it's these tasks right here that we have built and that we've automated that are going to make it possible for you to keep this app up, running, and professionally built, making it a safe environment for the users who are using your application for years down the road. So just wanted to throw that out there. But now to the exciting stuff. We're actually going to update the website to start including some of the content about why someone would want to mint this NFT and like some background info stuff. So let's go do that. So we're going to start off, and this is just text. I'm just adding straight up text into this. So I'm just going to kind of blow through this, adding some divs with some text, and you'll see what it looks like here in a minute. Again, each div just has a class name to show where the text belongs. And then down here at the bottom, I'm adding a new footer to this. And I have kind of like a pet peeve on this, right? Because with your app, I get that crypto is like pseudo-anonymous or pseudonymous. And it's kind of cool and trendy to be this unknown person. And that's fine for some parts of crypto. When it comes to your personal activity on crypto, sure, that's cool. And probably more than cool, it's probably prudent to do that. But when you're doing something like this, we are building an NFT site where we want people to mint our NFT. We're basically building a business, right? And so part of building that business, like businesses happen with people, you transact with people. And so where I'm getting with all of this is on your website, you really need an About Us section. Preferably an About Us page. In this case, I'm just doing an About Us section, but it's saying, hey, here is the actual human that built this. This is not a scammy site built by North Korean hackers or built by bots. It's not a ChatGPT site that was automatically created. There's a real human behind this. And if you want to talk to that human, here's that dude. And then finally, I'm going to have a link down here to the video so that people like yourself who come across the site and want to learn how this video was built, they will they'll be able to come and check out the video as well. So that is that. We've got our About Us section. We added the text. Let's just go over here to this thing. Let's fire up our site and see what it actually looks like. Well, it started, so that's cool. Fire up the old refresh here. And there is the text that we added. It could really look better, but I'm a horrible UI person, so this is what we're rolling with. And here's our NFT that we uploaded at the very first part of this video. None have been minted. Here's the footer that we added with my profile pic, ThirdWeb's logo, and then the YouTube logo going to the video. And let's actually mint the NFT because, that's kind of what we came here to do, right? Let's make sure that it actually works. So we got some estimated gas there. The NFT mint itself is free. And look at that, successfully claimed NFTs. And our total minted updated to 1 of infinity. And let's see, what else can we do here? I know one thing we want to do. Let's go back up here to the top. I'm going to grab this contract address. And then we're going to head over to the OpenSea testnet. And we're going to search for my contract address. Oh, look at that. There it is. And then there's the NFT owned by you, where you equals me. Next, we're going to update our README. Actually, it's already updated, but I'm going to show you what I did here. And we'll start by taking a look at the rendered version first. If we take a look at the top here, we've got our status badges for the build status and for the security scans that were done by Snyk. We've got the title of the project, what the project is about, and then some built with badges showing the different technologies that are used by this application, followed by getting started, i.e. how to get this project up and running for your own local development purposes. And if you want to contribute to the project, how you can do that. Finally, some contact information down below on how you can get a hold of me. But there's a couple of things I want to point out in this. For example, the badges you'll see are just marked down references, and I'll show you where those references come in because I tend to use this README template a lot. And so this just makes it easy to update it for different projects. So the rest is pretty straightforward Markdown. And then we'll come down here to this Markdown links and images. So up at the top, you saw that we had a build badge, and that Markdown reference is referencing this tag. And then that points to the URL, which actually is the URL provided by GitHub to show the status of that particular job. Same thing for the security badge. That's a GitHub Actions job. And so we can pull the badge.svg to show the final status of that job, whether it's passing, failing, that kind of stuff. For the technologies that I use, Node.js, Next.js, ThirdWeb, and Polygon, each of those, if we take a look at them up here, they consist of the badge, which is a URL format, and then the URL that it points to here. So when I want to update those, the Node.js badge comes from image.shields.io, and the URL points to the Node.js website. And so whenever I swap this README template out for different projects, if I'm using Python or Go or something besides Node.js, it makes it easy to just have all of those consolidated into one single place to make it easier to update and edit. So let's take a minute here to just pause and reflect on what we've done, because it feels like we may not have done much, but we've actually done quite a bit. And what I mean by that is we built out our website, put in our text in there of how we wanted it to look like, built the behavior that we wanted. And most importantly, let's talk about the tests, not only the tests that we wrote, but the tests that we didn't write. For example, a lot of the functionality from our website comes from these imports that we got from ThirdWeb. You know, the NFT metadata, the name, the description, the image, how many have been minted, whether or not this can be minted, if it can be minted or if it's sold out. All of that comes from these particular imports that we did. But if you think back to the tests that we wrote, we didn't write tests for any of that. We only wrote tests for the responses we get from those imports, the parts that we were focused on. And that's the benefits of using ThirdWeb whenever you're building this application or building Web3 applications, because it keeps you from having to write a ton of code. I mean, think about all of the code that's involved to figure out whether something's available to mint, what the NFT metadata is, and handle the Web3 transaction, and check that the transaction was successful and things like that. That's a bunch of code that we didn't have to write, and that allowed us to focus on writing the code that delivers our unique value proposition to the users of our website. So that's testing in a nutshell. We test the things that we're writing code for, and then we partner with reliable vendors like ThirdWeb and use their services, knowing that they've written tests on their side to handle the parts that they're exposing to us. The last thing I want to comment on here before moving on is this README. It's one of the things that I see is probably the most underutilized feature of every website. Because when you think about it, most people interact with your website through the GitHub repo from a developer's perspective, like the people contributing to your code, right? So the README is actually super important. It's the place that people see first when they hit your repo, and it should have all of the information they need to either use your project, contribute your project, or ask you questions about your project. Those are the main sections. And then specifically, if you're doing this for a portfolio website, if you're doing it professionally, it's good to share that information with your coworkers, teams, and more importantly, future you, because 6 months from now, when you're wondering who's the asshole that wrote this and didn't document it, the asshole is probably you. So from that perspective, you're doing future you a solid favor. But if you're doing this as a portfolio site to showcase your Web3 skills, you're going to be sending people to this repo, hoping that that triggers them into contacting you for an interview and hiring you. And so having a solid README is a must. So use this template, put the badges on there, update your contact info, and then just create really good documentation around how to use this project that you've built. And so now let's jump on to the next stage of this project. And we are finally ready to move on to the exciting part of this, the part that you probably thought we were going to get into right away. But we had to do some, lay some foundation work first, right? And that's done. So now we can go do all this production related stuff with full confidence that things are working as we expected. So the first thing we got to do is deploy our NFT to the Polygon main network. So if you'll notice, I'm signed into Third Web here, but using a different wallet because I have a development wallet and I have my production wallet. So we don't want those two to get commingled together. And we're going to use the Third Web Explorer here to go much like we did on deploying our contract to testnet, and just find our edition drop here in Third Web's Explorer. And we will hit deploy now. And then we got to upload our file. So that's in my downloads folder. And there's that. The name is the Hodler's Creed. Symbol. I don't think symbol matters a whole lot because this isn't a token. But we're going to call it THC. And then our description. We're going to put this in. And this is basically the Hodler's Creed. You can check it out after the video if you want. The thing I want to point out here is notice that I've got HTML break tags in there, which those should actually have little spaces in them. My copy paste foo has failed me. All right, so we got those in there, and that renders as text. And so this is kind of one of those iffy areas. The NFT metadata is stored as JSON text, so you can't really do anything consistently in terms of carriage return line feeds, line breaks, or HTML breaks. So I'm just choosing to go with HTML breaks, and then I will show you in just a few minutes where we actually tell that to render properly at, because there's really only one place that I care that it renders properly, and that's on the website that we're building here. So don't let me forget to point that out. Again, payout settings, we're doing this for free. So there's no payout settings, no royalties. And our chain, we are going to Polygon Matic, and we'll smack the old deploy now button. That should trigger our MetaMask transaction. There it is. So we're on thirdweb.com. We're deploying a proxy by implementation. I think that should actually say deploy implementation by proxy, but whatever. We've got our hardware wallet plugged in. We'll confirm that and confirmed that on my wallet, and we successfully deployed our contract. So now we have, we got to set up our NFT first, right? So we're going to go over to NFTs. We're going to do a single upload. Again, my NFT image looks just like the edition image because look, let's face it, I'm not the greatest graphics person in the world, so we're just trying to keep this simple. So we'll call this the Hodler's NFT. We'll say the holder of this NFT learned from 2022 and is commemorating with this NFT. All right. Again, properties, we don't have any properties from this or for this. Is there anything else we need to do on here? That's it. So we'll lazy mint the NFT. That's going to trigger a transaction. So let me run over to my wallet here. Actually, I guess I can wait. There we go. Confirming that that is our lazy mint. And we'll confirm. Okay, so we're good there. Should just take a few seconds, which is one of the benefits of using Matic, is it is a fairly quick network. Not that I'm biased or anything. I have no idea why I would be biased. But if you happen to know why I would be biased, leave it in the comment down below, and I'll do a drawing, give something away to anyone who can guess why I might be biased for Polygon. So that minted, we need to go in here and set up our claim conditions. So we'll add our initial claim phase. Phase 1 starts today, right now. Unlimited, charging 0 on the Matic network. Any wallet can claim, but you only get 1 per wallet, and that's all we want. You can also do claim eligibility. So like someone has to own one of your other NFTs to do it or something like that. We don't care about that. We want everyone to have one of these. And if we end up minting 7.4 billion of these NFTs, that's okay with me. All right, we'll sign the transaction to update the metadata. So I'll confirm that and then sign that on my hardware wallet. So that should be good in just a couple of seconds. That should actually be sent, so I don't think we need to wait there because I want to move on to this. And we're going to copy the address here. Oh, there we go. Claim phase is saved successfully. If we jump over to our index.tsx file, we've got our addition drop contract address specified here as the contract address when we deployed to the Mumbai network. So you might think that we're going to replace that now with our new contract that we deployed to Polygon mainnet, but that's actually not what we're going to do. Instead, we are going to create a new process.env or a new environment variable called next public contract. And so the way we're going to do this is when we run our build in the CI/CD process, we're going to inject an environment variable called next public contract that contains the contract address for our deployed contract on the Polygon mainnet. Now, there's a few reasons why I'm doing this. Number one, it's going to set it up so that when you're developing locally, you probably don't have that environment variable set up on your local system. So it's going to default to our contract here on the Mumbai testnet, which is the behavior that we want when we're developing locally. The other reason is we can set this value in our CI/CD process so that no one has to remember, track, or store what that contract address is. The CI/CD server knows, and it'll just inject it when it needs to happen, which kind of like leads me into like the whole purpose of DevOps. Like one of the overarching goals of DevOps is to automate the things that have to happen even when you don't know that they have to happen or don't remember that they have to happen. And so that's what we're doing here. There's plenty of other work for you to do. So we're just going to automate this so that you don't have to remember to do it on every build. The other thing that this allows us to do is provide a little bit of a buffer around who has access to our production contract, because in certain scenarios, this contract may be holding something that's worth quite a bit of value. And so doing it this way, we set that address in our CI/CD server, and we don't have to grant access to our third web dashboard to anyone other than those people who actually need in the dashboard to do things related to the contract. The other thing that we're going to change while we're here, we've got our active chain ID set to the Mumbai network. Obviously, that's not going to work for our production application. So we're going to do a very similar process here. We're going to have another environment variable called next public chain ID. And so if that environment variable exists, that's what's going to get used for our active chain ID. Otherwise, it's going to default to the Mumbai network. Now, getting this chain ID, I'm choosing to enter in the actual chain ID itself versus a string like Mumbai or Polygon, But if we take a look at the TypeScript typings for this, we can see that this is just an enum. And when you use Mumbai, it returns a value of 80,001. And for production, we want to use Polygon, which is a value of 137. So for our environment variable, we're going to set that environment variable equal to 137. You could set it to the string Polygon and do a little bit of string interpolation here, but to me, this feels a lot cleaner and consistent with how we're handling environment variables for the contract address as well. The last thing I want to do here is change up our build command in package.json. Instead of just saying next build, I'm going to change that to next build and next export, because we will be exporting this as a static HTML site because we're hosting it on Cloudflare pages. If you're hosting it on Vercel, you can just do a next build, but if you're hosting it outside of Vercel, you need to export it as static HTML. And that's true whether you're hosting on Cloudflare pages or GitHub pages or an S3 bucket or any other of the popular static site providers. We can now jump over to Cloudflare pages, and we're going to create a new project from our GitHub repository. Got the right GitHub account selected there, and I'm going to choose a repository that we've been working on this whole time. Click Begin Setup. Project name is fine. Main is our production branch. For the framework preset, I'm going to choose Next.js static HTML export. We talked about that a little bit, but I am going to change our build command to npm run build. Now that runs the same thing, but it does provide consistency in the command that CI/CD runs versus the command that you may run locally to test the build. That way everybody's doing the same thing the same way. Our output directory is going to be /out. And then we'll need to set those environment variables that we talked about. The first one is going to be, let's just go over here and grab it so I don't typo it. That's going to be our next public contract, and that's going to be set to the value of our contract on the Polygon mainnet. Our next one, again, copy and paste to eliminate typos. It's going to be our chain ID, and we looked at that enum. That's going to be a value of 137. Then I'm going to insert one here that we didn't talk about called node version, and I'm going to set that to the version of node that I'm running and have built this on, because otherwise Cloudflare pages will use node version 12 to build our project. And I know for a fact that's not going to work, because part of the video you didn't see was me troubleshooting why the build kept failing before I got to this point. So we'll hit save and deploy here, and we'll see what happens next. All right, so our deployment was successful. You can tell that by the little green stripe over here. And if we click on visit site, that should open a new window for us, takes us to our website, and there is our NFT from the Polygon mainnet. So all of our environment variables worked just like we were hoping to. There's one more thing we want to do here, and that's a custom domain, because I don't want to, like if we look over here, if I quit highlighting that stuff, under our deployments, the current domain name is f33b448d.holderscreed.pages.dev. Doesn't really roll off the tongue, right? So let's put it under a custom domain. So we'll set up a custom domain with one that I have already purchased, and that, as you might have guessed, is hodlerscreed.com. So we'll hit continue. It's going to set up the DNS record for me, and my DNS is hosted in Cloudflare, so it should take care of that for me automatically. So now our domain's active, so if we click on this, that's going to open up the website, hodlerscreed.com, loads up our content, pulls our metadata from the blockchain, the Polygon mainnet, no less, which is exactly what we want. And that is super cool. There's one last thing I want to show you here that's sort of like the coup de grace, the grand finale, the shootout at the OK Corral. I've got a pull request open here, and this just kind of summarizes all of the stuff that we've done in this video, because when I opened up this pull request, my Node.js tests ran, and those passed successfully. Our Snyk vulnerability scan passed. Our Snyk code analysis ran, and that passed as well. Snyk itself ran a manifest change detection to see if there were changes in the manifest. And then finally, this one is cool, and you haven't seen this one yet. Cloudflare Pages, when we opened up this pull request, deployed a preview environment for me. So it actually added a comment to my pull request here with the URL for the branch preview. And we can click on that, and that's going to open up. And the actual change I made here was just changing this little logo down in the footer. So we can verify that that change was exactly what we wanted. And that to me is pretty cool because all of that was automated, and it feels like a lot of work to set it up. But 100, 200, 300 pull requests from now, years down the road when you're still maintaining this, it's work that you're going to really appreciate that you took the time and effort to set up.